Cool. Thanks everyone for making time to be here. For the meeting today, I was just going to pull up the notes and we can go from there. So in terms of updates, we merged the pull request today for dropping Python 2.7 testing. So that doesn't mean that we're not, it should still run on Python 2.7, but we're not going to guarantee that anymore. And if people file bugs that are specific to Python 2.7, we will not address them. And then a pull request from Thibaut and Dom is now in. So I don't know if either of you would like to give a quick update on what that includes.
Oh, so that was simply an update on the preconditioning directives. Like before, if you had like a mapping in your regularization, it was not taking it into account. So, and it was making some tests for projection, etc. So now it just straight calls second derivative of the regularization. So it's much straightforward and more general. That's it.
Excellent.
And there is another one coming. There was like inconsistencies in the name of mapping for in potential fields between gravity and magnetic. So we're working on that with them. It's going to be a small pull request too, but just like to make things consistent between the two.
Is that still in progress, or is that ready to be merged?
I think it's ready on my side, but Dom has not had time to review it yet. So
sounds good. So then the next items that I see are both from Sarah. Would she like to?
Well, the first one was this question on time lapse, so I don't know whether you want to discuss this today. So whether and how we would address time lapse inversion in SimPEG, and if yes, which ones? So I put this slide there in the issue where you see basically 4 types of time lapse inversion.
Yeah,
so, yeah.
I've contributed to that issue thread too, if you want to look.
Yeah,
like I put some thoughts there already.
Somewhat,
just some thoughts.
Yeah, I saw it.
Sarah, just for people who haven't read through that, do you want to maybe give a bit of context? We can pull it up on the screen if that's.
Maybe show it, yeah, on the screen. So the thing is that until now, if I understand well, there's not been so much work with time-lapse data in SimPEG. So here I'm really talking about resistivity, but it could happen with other types of data. But often, like in groundwater communities or hydrogeophysics, this is the most used form of resistivity data because we want to look at processes. So at some point, it will be useful if you want to also talk to these communities to have at least one of the options available, or show how that can be done. And so what's typically done, so there you see these 4 points. So what you can do is just invert everything independently and then afterwards make a ratio or make differences to look at time-lapse, but that's, yeah, then you don't take any of the knowledge on the time evolution into account in the inversion. That's the disadvantage. And you take problems with noise that can be different at different time steps with you throughout the time line actually. So for example, if at some point you have bad electrode contact and you get some artifacts, this would be projected into your differences, which is a bad thing for because then you can get like, huge jumps from one type to another, and that's not what you want. Second thing that a lot of people do, if you go a bit up on the, so it's inverting directly the data ratios. Problem with that is that you're inverting a quantity which is much smaller than when you invert just the resistance. And so, yeah, you bump sometimes in things that are not very robust. So that works sometimes well and sometimes problematic.
Which I've not
No, so data is not very robust. And so what people do mostly is the third one is the difference inversion. So it's the Labrec method, where your data, where you have this term, which is the reference model actually, that you use to multiply the ratio. Sorry? Yeah, was there a question?
No.
Okay. And then the 4D, I don't know very well there's different options too, but that would really be like building a matrix with a fourth dimension and then applying any type of regularization you want on this fourth dimension, which can be different than the space dimension or the same or like several types. But then you would just have to define a regularization in the time dimension for your time steps, and everything is like just one big data set actually. And so I think the third one is something that normally you should be able to build quite. No, it's the fourth I think is easiest with SimPEG to put in practice, I think. But yeah, I don't know. I'm not yet enough into the maths to have an idea of what is easily feasible or less feasible with the code. So I just put a bit more in detail the option 3, which is done there in the next slide, where you see that just, yeah, you change the model and the data vector, and it can be with a reference model or just between every time. Like you can make the difference between the reference model and always the time step further. So it will be increasing the time, the delta t will be increasing, or you can always take the difference between the two time steps and keep the delta t the same, but move forward. Yeah, so a lot of options, and I just wanted to know, one, is it something you want to be trying to do with SimPEG, and two, if yes, how could we do that? And who would be interested to work on that with me, basically?
Like I just took a brief look the other day, and like first thing for me is like everything is still least square. So I think SimPEG is like we have all the tools to use all those least square, and then I have like I've put my thoughts in the other slide, but like on how I understood like the math you were showing, like or maybe there was some convention we would have just to agree on, because I was not sure what was fixed, what was moving in optimized. But I feel that if we want to make it happen, that like there would not be much things to change in the core code of SimPEG, but maybe like yeah, like.
So what do you mean with fixed? Is bias there? In the...
Oh, for example, like I was just rewriting, for example, your FID in your time lapse, and I guess the quantity you optimize right at this point is that just MK and your M naught is fixed. That's correct. So
that's the question. It could be. So if you say M naught is the bottom, also is, for example, if you have a process, for example, we are looking at an infiltration of a waterfront. Yeah, your M naught would be the time step just before infiltration, and then all the rest.
The value you're optimizing then is just MK in that case.
Yeah, in that case.
So then that part with D naught and M naught, it's completely fixed. So it's just a bias that you add to your data.
Yeah.
So that's what I was saying. So we can still write it as a FID with data minus the forward, but our data is now like the data at timescape plus the bias we had from the previous time. So
and of course, M naught is something that you first do one basic inversion for its reference time step.
Yeah.
And then you start your time.
So here I was just rewriting it to put it back into like a simple L2 square, but basically saying, okay, like the data now is our data plus the bias that we inherit from the previous time.
Yeah, something like that. Yeah.
Basically, you're saying you add the bias, so you want your data to fit and like to be like similarly biased than your recovery in your model. That's how I understand that. And I did kind of the same with your model functional, where you have like you have two least square terms, but with I saw after that there is like a M naught space and an M naught time, so maybe we will need to put definition of that, but like we can definitely write it as a simple least square term. So like SimPEG would be fairly like it's not a problem for SimPEG in that case.
If you say it's no problem, does that mean that I could actually, with what is there now, easily make 1 or 2 lines and do that, or you would have to build a new function or something that's
like I think like one thing I was thinking too is that so Lindsay a while ago now developed that combo objective function where you can basically like I have this term, and then you can just add them together in your objective function. So that's probably going to be very convenient in your case. And I guess after that it's going to be like it's basically I think it's the biggest impact going to be like managing the time, like the different times. So having like a fairly smart for loop to run with inversion and stuff. So like you will have to need a proper script for that. But like each individual, I think we don't have any modification to make for each single inversion, but you will need a script to manage the time in the different inversion at each time, and like take the information you need from the previous inversion and transfer it to the next one. So that would be but the objective function of the individual inversion, I feel that we can make it happen without.
I just got a quick question, like before thinking about the implementation. What's the features, like Sarah? What are the like feature that you want to image, like in time? Is it really smooth function, or is it changing a lot? What are the features?
Well, that's the big thing in this community. So it could be both. And if you have an infiltration front, for example. What you should picture is that your structure might change abruptly. So in time things will be rather smooth maybe, but in space this might cause abrupt features, let's say. So maybe I should be able to draw that. Think of a plume or some kind of pollution. If you would look at the absolute inversion, you would have something which is quite smooth. When you invert differences, you will have like a bulb, which has a high value, and then all the rest, which is a low value. And this bulb might grow smaller or bigger, or so.
You want to draw?
Yeah.
You can draw from.
Yeah. Do I have to do you, or do you see what I mean? So.
More for side, because you didn't see what you mean.
So if you would just have, let's say we have a pollution and something is like coming in here. This would be the feature. If you have an absolute inversion, you would maybe see a bit that there is a contrast. Right?
For the cam, you can't see it.
Can I just... do they see me or no? But it will be too hard to see, no?
Maybe. Try.
So in the absolute inversion, you will maybe see a bit what's happening, but it's only when you start to make a difference of 2 time steps that you will really see like something like this here. And the next difference, it will become maybe a bit smaller. And in the next difference, it will be something like this. You see what I mean? And so this is what we need to try to invert. But I don't know, I think the space constraint can be quite smooth here. But the spatial constraint here should be not too smooth. Because you are actually inverting the ratios, and ratios can have some quite strong contrasts inside. Does that make sense? Or am I saying that?
No, I mean that's fine. It'll all come down to effectively what is your
yeah. So it depends on the process.
Yeah, what you're trying to model, what you're defining as your model.
Or same with an infiltration. It could be the time could be very abrupt. Actually, you could have a very abrupt change between time 1 and time 2 if you have an infiltration front passing by very quick and then afterwards very smooth transition only when the diffusion starts. So first convection and diffusion. So yeah, thinking there's no real rule. That depends really on the physics of the process you're trying to look at. So it should be the user who should be able to define, okay, I expect smoothness in space or in time, and then I will adapt my regularization to that.
Yeah.
So that's why I think the 4D inversion is becoming quite popular, because there you can play more with these things, but it's also dangerous. I think you should know what you're doing there.
Is there a, like a simplest example that you could think of that you could actually sort of add tangibility and use as kind of like a test case to program up a number of different scenarios, and so we have an opportunity to kind of evaluate, you know, the pros and the cons.
Yeah, of course. Actually, even on the, I was in previous data and previous models, but even on the thing that I'm trying to invert now, I have also the mechanistic hydrological model, so where we could do synthetic modeling of this kind of thing. I could generate with a physical function different things. Yeah.
Mm-hmm.
So, and I have the data, I have the model, and we could do something like that. So that's actually the idea of what I want to try to do here. So my main question was, is this of interest for you who would like to work on that with me and with the aim of really publishing something? Of course, too, with that. But if you tell me that's not one of our priorities, then I would focus on other aspects of.
I think it's a very interesting aspect, and you know, it's been something that's kind of on the books for quite some time. And also, there's been a fair bit of work that's been done. LDAT and some of his students have worked.
It's not a new problem.
And but we don't really have, you know, haven't really addressed that with functionality explicitly in SimPEG, and so it would be nice to have.
Mm-hmm.
So I think that would be really good.
Okay. And so who would be, who would like to work on that and who would have time to work on that actually? I think I'll need help. You can tell me this or that, but I think it will take me too much time to bring this really to application if I have to do it all by myself. So it would be better to work in a team like,
I think the 4D problem is a day of work to wire it, and after that it's just to you to test it. So I can help you out setting it up, or if you want, I can help you out setting it up. And then
and I'm happy to jump in as well too.
Okay.
I don't think it's hard.
We'll just set up a small team then. Okay.
Yeah, I mean, because like in terms of the implementation, there's just a couple new pieces that we need to define for like how the data misfit is defined and how the objective function is defined. But those are like very isolated pieces. So as Dom said, I don't think this should be a complicated thing to do.
Well, 4D, it will just be a directive, right? The rest is just a wire maps for each of the model in time, and then misfit functions for each, and it's just a directive to tie them all together.
Yeah, but we need like the data misfit function that takes a difference, because you want to store. We can get into this afterwards, but you want to store like the data from the previous time step and the synthetic data from the previous time step and not recompute those.
Gotcha, yeah.
But
there's one issue that's also an issue that is causing the fact that people often still do just normal inversions for each time step and not timeless, is that if you filter, so in timeless inversion, your data vector length cannot change, of course, to make these difference or these ratios between two time steps. So you cannot filter differently for different time steps. So you cannot say like, this time I have one particle which is causing problems, I'll delete it. So either we need some kind of weighing that can be different for different time steps.
And crush it.
But this kind of functionality needs to be either there if you do that kind of stuff, or needs to find a solution for that. Because if you cannot, if you have like hundreds of days, most probably you will have somewhere something to delete or some problems to deal with before, to be sure that the electrode is maybe not working and take it out.
Turn it off, yeah.
Okay, so how should we go about and what's the strategy here? Can we?
I think pick one, and then we'll sketch out what we need to write.
Yeah, I think really defining what you'd like to have as far as both for the hydrogeologic model as well as for the ERT, and then just doing time stepping for the forward problem to see what you get out, and then now with that, that's the objective.
We work on the synthetic and
definitely work on the synthetic.
Okay, that's my motivation.
Yeah, and then I would potentially suggest that we do the difference inversion first and then the 4D I think both should be fairly straightforward, but it would be nice to have both to compare.
I think this might be an opportunity to take a lot of the existing approaches that are out there that people are kind of commonly using, and just to make a comparison on a particular system. That would be really interesting.
If you want to publish on it, just like implementing one of these things that already exist for like some 20 or 30 years even, I think, will probably not be publishable either. So then it's just for the sake of implementing it. Yeah. If you would want to make it, to make it publishable, then we should probably do something like Doug is saying, like trying to compare all different.
Yeah, and looking at the different questions that come, because you're going to define your data differently, you're going to define the model differently, you're going to have different uncertainties, and just trying to find it like, okay, if I'm taking this route, this is the assumptions that I'm making, and these are the definitions I want, and I'm going to end up with this. Now I take this route,
that's much
and then
more, but yeah.
No, but it would be very interesting, and then that would also be generic in the sense that anybody else who wanted to do something, perhaps with different physics involved, but still some kind of dynamic system, could build upon that, and that would make it really useful.
Has somebody done a methodology study of comparing different methods?
Like Thomas Günther, so in Becht, did implement already 3 or 4 options, but he's only presented it once on this Gelman workshop. It's like the European geophysics community gathers once per year in Vienna in December, and there they presented that, but they didn't really publish a paper on that issue. There is a recent paper which looks at error analysis for time-lapse, because you can imagine that the error level of looking at absolute data or the error level of differences is actually different. So you cannot use the same error model for differences as for, and actually everybody was doing that up till last year. So there's a paper on that, but not really a methodological paper, which is very.
Yeah. And what I can see happening too is that, like in the formulation for the time-lapse inversion you gave, is like as you're adding that bias at each step, like if your first inversion doesn't fit well with data, then you add a huge bias that you may not fit well, and you just basically at the last time step you just start fitting the data anymore because you have too much bias.
Yeah, that's good. So the dealing with errors is an issue. Especially because we know that, and that's, I've not seen, I know whether you have ideas, but I've not seen an approach yet that can take into account, or that takes into account errors varying over time. So you know that, for example, if you're monitoring a drying front, in the beginning you will have less errors and good quality data, and towards the end, soil is drying out, electrode contact will deteriorate, and so on. And so you know that this error will be higher. But most often you just give one constant error term to your time-lapse inversion, and it's running like that, which is actually completely wrong because.
Yeah, so you will change your WD matrix at each direction.
It should do that.
In if you talk about time domain EM, then each individual time channel probably has its own its own error bars, right? And even if you're going to assign, a percentage, then earlier time channels might have a different percentage than late time channel.
So do you then also adapt the regularization factor to that?
No, because the most important thing is just to estimate the uncertainties in the data, and then that kind of normalizes all of the data because you divide it.
So it doesn't affect the regularization term as such?
No.
Yeah, so what I propose is that next week I'll be skiing with my family, so maybe we can start that thing after that. So towards the end of March, beginning of April, set up a small team and really work on it. Okay.
Excellent. And Sarah, it looks like you had another question about I/O for DC.
Sorry? The second point there? Yeah, that was just a question I had. So like right now there's not a lot on data filtering or data processing in the I/O utils, and I think that might be useful. I was just wondering what is the philosophy I should adopt. So for example, you load a data set with a certain number of protocols, then you might analyze, like already when you just check which are the reciprocals. You will reduce the data set because you will have to reshape. You will take out the reciprocals, take their average resistance as the resistance you put in for the protocol. Yeah, I'm following. And so already you will reduce your data set. Then you might say, okay, the data is my error, I will take them out. So my survey will change actually. I will like take out values. How do you want to create the functions that will operate on the I/O objects? Because you will first import data, you will create a survey, and then the idea would be that on that survey you can do this kind of data analysis, I suppose. Because otherwise it will be too complicated.
John? This is your cue.
I think I've done a bunch of this like tools for data processing, but all the way from time series.
Yeah.
So it's not operating on there. The way that it's built is that you'll build your survey after all that stuff.
Mm.
You'll build that object and then all the data before you.
Yeah, that's what I always did,
Yeah.
but doesn't it make sense to have some standard operation that everybody does on resistivity data when you load your survey?
Again, I'm thinking that you've done that previous, like already before bringing it into all this kind of stuff. The tools that I have is just like you got a time series, bring it in, you can stack it, do any kind of analysis you want on it, and then whatever you have selected as data that you like, you just send it into a method that just makes a survey object.
That's the same idea as this REDA package then. So these guys of Ghibli, so Bon and Thomas Winter, they build a separate package in Python, which is really under construction, for data processing actually. So you load your data in there, and then you can do a whole bunch of operations. They're very limited now, but and then you would like be able to give an output to any type of program that you want to use for the inversion. So then I see. So these kind of functions that I'm trying to build right now for my data, you could probably discuss them when we get back to these guys on the REDA package. But ideally there we would provide functions for different devices to load data files, then ways to process the data, and then different functions to, like for example, write input for SimPEG, write input for verify, so that all the different codes can also take the output of this thing.
So yeah, I've started something like that. I call it a patch, and that holds readings and dipoles.
Then you should really be good at this point.
Okay, yeah, it's on the processing branch on there. I've got most of it pushed. However, right now it's just built for the PS data to be provided, but it can. Like I said, the object is dipoles and readings. So if you just have to build a bit of an IO to take in anything to build that patch, and then I got functions and methods for call the data by geometric factors, anything like that, like all that kind of stuff. Yeah.
Because I think everybody builds it every time, and it's be good to have somewhere.
So that's the package, like in terms of the SimPEG organization and processing.
Okay, so that's not something I get automatically when I install it with an
You need to go on Git. We need to set you up to Git so you can get all the source codes. Yeah. It'll be much easier for you because all the stuff that John's talking about is all in there.
Okay, yeah, that would be good. Anyway, it's good for me to learn writing Python to reprogram those things. But,
you have an image somewhere. I remember that package that like shows some of the stuff you're doing. Maybe that would be.
I don't know if I have it on there.
I think. Sorry, was somebody saying something?
Yeah.
Can you guys hear me?
Yeah, go for it.
So I think Sarah brings up a really good point that we need to actually standardize and improve the data class. Because right now that's sort of an underutilized, like not very well laid out module within SimPEG right now. And so it'd be really nice if we could pass around a SimPEG data object and do some of the culling and like filtering and that sort of thing that you're talking about. So I think what we should think about trying to do is perhaps like treat the I/O much more as a utility thing. So don't actually think about perhaps like operating on an I/O object. What I think that we should do is basically use I/O to create a data object. And then when you're going to do your processing and stuff like that, you're acting on a data object and a new data object comes out. Does that make sense?
Where's the data class, Lindsay?
Oh, it's like, it doesn't really do anything right now. It does exist. I believe it's in the survey.py. I think, let me see. We started sketching out some issues. Gutney's been, a while back, he was the one who sort of was always pushing for us to improve the data class. And so I think there are some issues.
If the idea is that this type of thing should be done before going to SimPEG, then maybe we don't need to put it in the data class.
I think the data class in SimPEG is valuable because, like you said, people are always going to need to be processing it. We can just read in the data, put it in the data object,
and then
we can do whatever we need to
and
the data
then go to
object
the survey
and pass a subset of the full data object onto the survey to do our modeling.
For me, it's not. I mean, I must say that sometimes it's a bit messy now. Like there's a lot of things in this IO thing you can do with EM static too, and so yeah, probably you need to do some ordering there to know exactly what the IDs of each of these classes.
Yeah, so like right now, all the data class does is it lets you basically look up what a datum is by source and receiver pair, rather than having to like remember how everything is sorted. It talks to the survey to figure out what a, like when you give it a source and a receiver, what that data value should be. And so I think this is like a container that's actually extremely valuable and should stay fairly lightweight. But this is something that we should give a bit more thought to how we can take better advantage of that and like what needs to be added, perhaps.
Okay. Well, let me know, and I can also talk with you maybe together.
Put some stuff together.
Lindsay?
What do you tend to do with your reciprocal data?
So usually what I do is I use it as filter to filter the data, and also to set up an error model, which I then use to give errors to the inversion.
So you just look at the difference between the two.
Yeah, relative
treating the
difference, and
reciprocal
then
data
I
and-
fit them all to these points, like that gives me an error as a function of resistance, which is a log model actually. Log linear model, yeah.
Okay, we'll talk now.
Yeah. And I know we use that as function as an envelope also to filter. So everything that's like 2 times outside of this envelope, we would then from the data set.
Okay.
Doggy, did you have a question?
Just quick comment about the like reciprocal data. Currently, SimPEG kind of think that as a different data set. So computationally, that's going to be expensive.
Yeah, but that's why they have to be out. That's what I mean. So you have to first filter, like find them, use them to make your error model, and then merge them. So
right.
I
think that. Yeah, I'm not sure about the other things, but that'll be pretty useful, like directly, because I mean.
So I did that yesterday. That works now. I have a sort normal reciprocal function that sorts out based just on the quadrupoles, like the.
Okay.
Of AVMN, it sorts out which are the reciprocals and then calculates the difference and the average resistance. I think it could be a good check actually when people load data into SimPEG that if it still contains reciprocals that you say don't invert it because actually it creates often large misfits too. If they forget to filter out or to merge, you give the inversion twice the same, exactly the same value actually with different.
Yeah.
So.
If that's what, I mean, in principle, that's okay. And if you've got an uncertainty that is appropriate for that datum, then you help your final result by square root 2, right?
Yeah, okay, yeah.
2 data.
If your uncertainties are can absorb the level.
But here's where there's a lot of information in the reciprocal data itself. It's just kind of interesting to know how you actually.
Yeah, and so we can talk about that. Yeah, I just do what I took once from a paper.
Lindsay?
Yep.
Is there a link between the development of the simulation class and the data class?
Yeah, but actually in a lot of ways, the development I think can be somewhat independent, not strictly so. But I don't think that the advancement of the simulation class strictly changes things that we should be doing with the data class.
Okay.
Yeah. Dom and John, did you want to update us on mag gradiometry?
Yeah, for sure. Look at that. So John finished writing the kernel for. I'll share my screen 1 second. Me and the trackpad. Okay. So that took a few iterations, but so we have the analytics for. So this
Gold
is the
star, John. It's like,
Don't push me in the right direction.
it's like, ah.
I was trying to be fancy, trying to vectorize it, make sure that
we'll make it cheaper later. So this is the analytics for a sphere, all right? And then John wrote the kernel function for sorry, my battery is dying. 1 second for.
Yeah, no problem.
No power to this. There we go. Everything's gonna shut down and okay, good. We have electricity. Okay, and so we have the kernel function for it using the integral. So we got the paper, and then John just wrote it down. So this is the residual between the two, and then just did the usual test of decreasing the size of the sphere and to look at the residual.
Between the two, sorry?
Oh, it's numerical. It's just numerical noise, right? Because yeah, it's just
Discretization.
Yeah.
Sorry, two discretizations? I missed it.
So one is a sphere, is a perfect analytic solution for a sphere, and the other one is for a cube.
Ah, okay.
All right. So they will deviate from like numerical. And as the sphere decreases, then the residual between the two also decreases.
Nice.
So it's very topical. Now we had to deal with multiple data, multiple receiver types. So the question is, how do we want to organize this? Because before we were only dealing with TMI, so a single data per receiver. But now our receivers have multiple components, right? So we need to organize it. Do we want to have one survey per data type, or are we stacking everything?
No, I mean, so I would think of it like EM, for example. So you can still, like, we can have a 3-component receiver at every location, but each of those is actually a different receiver. So it's not a different survey, but it's the receiver that you're adding to the receiver list.
Yeah, sounds good.
But each of these components, because Dom, the point that I saw that caught my eye here is the components, because it's integral formulation, like your point about sort of treating those as like a different frequency, the way we do in the EM sense.
Yeah.
It's well taken, because each of those is, correct me if I'm wrong, but independently computed. Is that correct?
That's correct, yeah. But we kind of want to be able to batch the calculations, because they're reusing a lot of the same functions.
Yeah.
So, and when we parallelize the calculations, we kind of don't want to have to send it multiple times. It's just harder. It's going to be easier if we can send it all at once, you know?
Yeah.
Yeah.
So, yeah, so I would think about trying to treat them all in one receiver list. But then what you're going to need to do is we're going to need to basically be able to sort receivers, I guess, so that you know
which was it of G, yeah.
Which should not be like a crazy thing to do, I don't think.
No, it's just reorganizing the way yeah, the way we're stacking the matrix, right? Because before there was each row was independent, but now we're gonna have multiple components coming out of the same call. But yeah, no, that makes sense. You answered the question, and we'll just we'll index it.
Okay. Yeah, we can iterate a bit on this. And two, like if you feel like the simulation class stuff is needed, I'm hoping to pick that up probably in 2 weeks. I'm away next week. But hopefully the week afterwards we can start hitting on that a bit.
Okay, well, next week I think we'll be ready to invert, and then we can always reshuffle it the way we want afterwards.
Yeah, excellent. That's really exciting.
And then we'll have MVI. We'll have mag radiometry MVI because it's all for free.
Yeah. Oh, and while you're at it, if for the analytic, I think that probably is like well suited for the GeoAna package.
Yeah. Okay. Yeah, because I think currently it's kind of yeah. Okay, that's good. I'll move it.
I mean, you can leave it in there for now and like generate the pull request and all that. Like that's totally fine, and then we can parse it out like while we're sort of reviewing it. It doesn't much matter.
Where's GeoAna under what?
It's the one on the right.
Yeah.
Your screen. Yeah.
Right on. Yeah, sounds good. I'll do a PR on this.
Okay. Excellent.
Cool.
That's exciting. That's really exciting.
So, Dom, are you inverting both mag and mag radiometry data there? Is that what system measures?
I think, John, what are you going to collect TMI at the same time that you connect? Yeah.
Yeah. Shouldn't be too much.
Because I think it will be nice to have kind of like these wavelengths, you know, the difference.
Okay. Yeah.
Graded figure geometry is going to be higher frequency, and then TMI is going to have a lot more longer. Yeah. And then we can stack everything into one bin matrix. Yeah.
Cool.
It kind of allows the potential for revisiting the issue about sensitivity weightings then too. Because one is 1 over R cubed, the other is 1 over R4. I don't think there's ever been a clear answer on like, okay, what sort of weightings do you want to do, or how do you want to approach that if you're using those two different types of sensitivities together. So it'd be interesting to just revisit that if you've got the power to do it.
Yeah. And then we'll be able to revamp the grav, add grav gradiometry.
Yeah, exactly. It's the exactly the same issue.
Exactly. Yeah.
Then the last item on the list is, Doug, you created the issue about data misfit. Do you want to give a bit of an overview of what you're thinking there?
Yeah, it's just trying to make sure that within SimPEG and within our papers and how we're talking about things, that when we refer to something called misfit function, that we actually know exactly what it is. And if when you're doing the inversion, and especially when you're working with L2, then you have a you have a norm of a vector. So you've got a misfit vector. You take the norm. Generally, it's an L2. It's an L2 norm. And then we would just write that as the norm of the data. In fact, that's just what we were looking at. All of the the phi d's were just the norms. Yeah. Okay. But within SimPEG, everything is hard coded so that there's a half.
Yeah,
so,
I saw that.
Yeah. So that it comes up to be a half. So that the misfit, the expected value of the misfit is then n over 2, which I mean is okay, but it can get confusing. And I guess the thing that I was wondering about was, just kind of discussing, as a group, what kinds of things would be, simple to work with and yet unambiguous from the point of view of what we're getting at. the issue of hard coding a half, I mean, the half is really natural for the optimization problem. But if I ask you, give me the L2 norm of a vector, you would not put in a half of this. That's just something that's of convenience for the optimization, since we've got a square and we're going to take a derivative and we get rid of this crazy factor. But if you start now to also think about different norms, so if we use the p norm for a misfit, which we could use a 1. Then the factor of a half in front of that thing no longer makes any sense.
No, and also I was
Can I ask a question there?
Yeah.
So Dom, correct me if I'm wrong, but you're still squaring whatever norm it is, right? You're not taking it to the power of p. Is that correct, or am I misunderstanding that?
Well, because it depends when you linearize it, then that p factor, you can get rid of it. But Doug's point is that if you write it as a norm, then it would be a 1 over p in front of it, yes, as is. If you non-linearized, yeah.
Okay.
What I was wondering, so the misfit you get out, like at the end of the output. So if I would want, I'm also just thinking of the data side. So the misfit should tell me something, actually that value has the units of my data normally. That's right, yeah? It's in ohm actually.
Sorry, one more time.
So if I would want to interpret physically, like how big is my misfit, I would like to feel that. What's coming out of SimPEG now is that that's divided by 2. That's not the difference. Only it's the difference with divided by 2. Like it's not what we call a root mean square error.
Like this, it's like the sum of the square errored and divided by 2.
Because a lot of papers, people will mention like this is my version and my RMS was this.
Right. So then you could take, in order to get that, you'd take the norm vector divided by n and then take the square root.
So in our case, if I would want to give a value that's comparable to that, I should do times 2 and then
times 2, then divide by n and then take the
and then I only have the same value. That's indeed a bit confusing.
Yeah, like the data misfit is your unit square right now.
Because at some point, what I actually want to know is like my relative RMS, so like what percentage of my average value of R how does my error relate to my resistances also? I want to know that. For example, if I measure overall like resistance is around 100 ohm, like what is my RMS compared to that value?
Sorry.
Relate that to each other.
Sorry, like right now the data misfit is unitless because we divide by the standard deviation. So it's already relative, but it's a sum of the square errors.
I am actually quite confused.
Yeah, divided by 2.
Yeah, divided by 2.
That's the. I guess I'm not saying we should do one thing or the other, but what I am saying is that when we do the inversion, that we have phi is equal to phi d plus beta phi m or r, right? And so we're going to refer within the context of the inversion to phi d as being a misfit function and phi m as being some kind of regularization function. So I think those terms we do not want to touch. But from extracting out of that to go into phi d, there's potentially extra coefficients that could hit half. But if we have two data sets, for instance, then I've got a norm of 1 plus maybe something to help balancing the norm of the other. We're going to lump the whole thing into phi e. And to always kind of keep track of what.
Sorry to interject. Conceptually, that's not what we do in SimPEG, just to be clear.
So what do you do?
Well, so like each of those would just be evaluated independently. So if you have 2 data misfits, like, so we've got my gravity data. This is going to be 1/2 times the L2 norm of the residual squared. And then we can add magnetic data, and we can perhaps throw a weighting factor in there. But then the misfit term, again, in that case, the way that it's defined is 1/2 of the L2 norm of that residual squared.
Okay, yeah.
Sorry, I didn't mean to interrupt. I just wanted to clarify.
That's not what you said?
Yeah, but when we're talking about, you know, just as we were writing down what Sarah had earlier, then we lump everything into phi d and we call it our misfit. When we actually, you know, as long as when we're parsing it out, we know that, you know, this component here has got, you know, a specific value, and that, you know, if there's two data objects, then we actually know what the norm is for each of them, then that's fine. And the same is true with model objective function, of course, right? Because we've got a WS, a WX, WY, right? So when the thing that's really important, I think, for the user is to know what those individual contributions are, right? And I think that's all now extracted from most of the SimPEG routines, that you do know what each of those are, right? And I guess now each one of those is always going to be defined as 1/2 of something. Is that correct?
That's correct.
So if I wanted to do an inverse problem in which I said, okay, I want to have as kind of a priori bound that, you know, the norm of the model be less than or equal to something. And if I wanted to put that into, so that'd be the sum of, you know, the norm of M, okay, and I wanted to have that less than something, then I've got to be sure that within SimPEG, if I'm referring to this, I've always got this additional factor of 1/2.
Yeah, and so I totally appreciate that.
Can we debate this a half, Rob?
Well, it's just that I think as we're going through, and especially as we're kind of developing the course and things like that, I think it's important to be really clear on a couple of these things so that we don't get tripped up, because I find myself sometimes getting confused between, you know, a misfit that's coming out of SimPEG or a misfit that we're talking about, even when we're, you know, describing the mathematics on the page.
Like, so what's the reason to keep that 1/2? If everything is always multiplied by 1/2, like it's just a constant coming out, like why are we giving ourselves that trouble? What's the, I don't understand.
I mean, the only reason it was there is it makes derivatives like slightly easier. So either we have the 1/2 in front and then you don't have a 2 in the derivative, or we don't have the 1/2 in front and we have a 2 in the derivative. Like, it really doesn't matter. It's just often, like, by convention, people write like the statement of the objective function as 1/2 of the L2 norm of a residual squared. And so we just included the 1/2 in the data misfit. There's absolutely nothing stopping us from pulling that out.
Yeah.
And so, like, I think that's something we can think about doing. It will take some time to make sure that we, like,
you've got data misfit for two different things, and it's a
I
factor
would call
of
what you had with the 2, I would call it the data functional, not the data misfit.
I would
the
just,
data misfit is the root mean square error. That's the data misfit.
I would be tempted to just throw the 2 in the derivatives, because no one looks at the derivatives ever. So you just bury it in you know, in the gradient, and then the misfit is the misfit, and the norm is the norm.
Yep, I think, like, if there's no objections to that, I think that that's like a very fair thing to do. We just have to be careful when we actually generate this pull request, because it's baked throughout SimPEG, right? So we need to go in and fix the regularization. We need to fix the data misfit. We need to fix all the directives for the target misfit.
Yes.
And then we need to fix wherever we have RMS defined.
Yes.
And so it'll just take some thought, but I think this is something we can
Like, is it good?
I think so, because we're gonna have that conversation every time we need to explain to people, well, it's your misfit, but not really. It's ×2 because we have a half in front of it. If we have to explain this every time, I would say, let's just spend 2 days and then wipe it.
I don't know. Just just depend on how you define it at the beginning, and then it sticks. Yeah.
Or you just generate a small explanation on the website or a notebook that explains why you have to do ×2. But the name, it's about the names.
It's kind of about the name.
It's confusing, but it's,
Well, and how now is when you write the model, we've got many components for the model objective function and regularization function. And how are they written out? Are the alphas in front of them, or do we just write out the the value of the norm itself?
So, Doug, when you say norm, what are you talking about?
I'm talking about the 2 vertical brackets and the and the vector m in so if I look into a mathematical textbook and I say I want the L2 or the LP norm of something, then they're going to give me an explicit expression of sum with elements raised to a particular power.
Okay, so the way that it happens in the regularization right now, like if we look at, Dom, could you pull up like the Tikhonov? The one, like, yeah, Tikhonov or simple, doesn't much matter.
But I do follow Thibault. Is that really something you want to put it as priority? I mean, it can be a lot of work.
No, I think I'm not really suggesting that we go in and alter SimPEG. I think it's really a matter of what we refer to things as and what is actually written
Look
out.
for the call.
If it's a point of confusion, though, this is a very easy change to make, and like I think our terminology should reflect the code always. And so if we want to define like the objective function as, so if we want to define, an objective function as a norm of something squared, without the factor of a half, then let's do that. That's not a challenging thing to do. What happens right now? Do you have the Tikhonov?
Well, Tikhonov is taking the call from the base, so this is the base.
Okay, that's confusing to show, but that's fine.
I chose a 0.5.
Yeah, actually, Don, can you show just the Tikhonov? Because I think the instantiation is like rather simple. So what happens in the Tikhonov is we have, let's just consider a 1D inverse problem. So all we're going to have, and we're just going to go up to the first derivative. So we have a smallness component and a derivative on the x component, right? So what Dom is showing here, when you see the objective functions, so what this does is it's basically just going to add up each of these things with with weights between them. So in this case, we have a smallness term, and so the way that is currently defined is 1/2 of the L2 norm of m minus m ref squared. And then we have the smoothness, which is 1/2 of the L2 norm of the x derivative of m squared. And then in between each of those, we have the alpha s and the alpha x. So when this thing is evaluated, we say, okay, what does my smallness term evaluate to? Please multiply that by alpha s and add that to whatever my smoothness evaluates to multiplied by alpha x. Does that make sense?
Sure. Okay. Do you ever write out or generate what the full phi m is, and then you list phi d, beta, phi m as function of iterations?
Yeah.
There is some output table, but I must say I did not understand very well what was what in that table. So I wanted to ask you guys about that.
We can talk about it. Yeah.
Probably it relates to this discussion of today that we just put a word which is like a bit weird.
But okay, so everything that's going to come out of they're even for the model of objective function terms are all going to be multiplied by half.
They're all half.
Yeah.
Yeah.
And the table that the output gives, is it already multiplied?
You see-
Or it's not multiplied?
This is the data
It's
misfit.
multiplied,
This
yeah.
is the data misfit.
Yeah,
That's the real mistake then.
And this is the
It's actually
regularization.
1/2 of the.
It's the one, so it's not thanks to it.
We don't
The
do a
user
times
should-
two.
Yeah, the user should do that himself, he wants to write that.
0.5.
The user-
Those are the
user should do
2.5
that
to me.
himself.
But that's easy. We just put it in the gradient instead. Put a 2 there.
Yeah.
And it's done.
Yeah, so like if this is a point of confusion, let's address it on the issue. So if anyone is opposed to us moving the half to a factor of 2 in the derivative, chime in on the issue. Otherwise, we can generate a pull request and change this, if that clears up the confusion.
I
That made
actually
me
think
happy.
it would clear up a lot. And I think as Don says, it prevents us that every time we talk to somebody, we don't have to explain, but, oh, yeah, but we're finding a factor 2. Thibault objects, okay?
Yeah,
Thibault?
but because I feel like if you look at other codes to, like, for example, when Sarah came, she was thinking that the data misfit would, like, target would be 1, because some codes, they also normalize by the number of
Sure,
that.
fine.
So we're just never gonna get it right. We have to explicit it in
It just
any
has to
case.
be clear, yeah.
Yeah, so like, are we normalizing by the number of data? Are we normalizing by 2? Are we normalizing by anything? All 3 are valid, but in any case, any choice we take, we need to be upfront about it in the documentation. So, yeah, it's just like I don't think that clearing that would I don't think like removing the 1/2 will actually clear the problem. It's just like we choose another convention, we make the change, but we still have to be clear about
Yeah.
it.
If I gave you a vector M,
Yeah,
and I asked you to give me the L2 norm of that vector, then what would you do?
yeah, just the norm. But we like here we talk about half of the norm. It's just just a definition.
The question is maybe who will do all this work? So if Thibault has to do it and he's not agreeing, then it's maybe not.
Yeah.
That's the point, maybe.
Talking about documentation stuff, I was going to start working on that pretty shortly. So if you guys come to consensus and you tell me what this is,
What is it?
if you come to consensus on how you want to formulate this, what convention you want to use, it's consistent. Document it. So if you're worried about who's going to go and do it, I'm the guy. I'm the one who's going to try and document.
Well, this is actually why I'm bringing it up now, because we're putting together stuff in course for Argentina. It's a time for us to, kind of, re-look back and, develop, examples and docs that are kind of completely clear.
So what you, in the code like R2D, you get also an RMS every time. What is that RMS?
We don't generally work with the RMS in SimPEG. So if you want to compute it, you can, but it doesn't have any internal meaning in SimPEG.
Because at some point you want to be able to give some quality indicator that is understandable by all users of the same technology in your paper. No? You want to be able to say, okay, this is my fit somewhere. No?
Well, it would be very easy to, at the end of the day to compute what the RMS error is. I mean, just divide by n and take the square root.
Isn't that an easier?
Well, I'm not sure that, I think perhaps depending on, which, where you're coming from and what you've been particularly used to, that like, okay, this is the norm or not.
But it's not about used to. I'm confused actually. If, probably in several papers you get numbers that you cannot really compare with each other.
I think in all of the work that has ever come out of here, we've always listed the number of data. And, we have a phi d, which is, expectation of that, of the L2 norm, is equal to n, the number of data. And that's kind of the thing that we generally kind of worked with over the years. So if you have that, then you can easily divide by, like if you get an expected, if your phi d misfit is equal to n, the number of data, then your RMS error is equal to 1.
Yeah.
Right? So you take whatever you got, Divide by n, take square root, you're good to go.
So what you said, yeah. I'm not used to an RMS equal to 1. I'm used to like a relative RMS and a chi-square that needs to be 1.
Yeah, so the chi-square that needs to be 1 is when you normalize by the number of data. But if you don't normalize by the number of data, this is n, or like divided by 2. So there, it's just, it's like, is the normalization 1 over half, 1 over 2, or number of data? Yeah.
Well, it's important because it's kind of communicating it. Otherwise, if you're thinking one thing and somebody else is thinking by half or 1 over n, I mean, you're not on the same line.
Again, I think it's important that you can compare quality of your versions also between papers. Unrespected, or how you say, not depending on the code, or that you just can say, like, how would you do now if you would give, like the thing I said about benchmarking, if you would give the same data set and ask all people that have developed version code to convert this data set, and how would you compare them? You would need some kind of indicator that needs to, it's the same for all of them, no?
Even that is a question. How do you quantify a good model versus a bad model?
Yeah, but I mean, that's important, no?
It's important, but
Why?
yeah,
It's a non-true.
Why?
Because pixel by pixel, it might be good, but geologically, it might be stupid.
All right, so we're about 20 minutes over, so I don't interrupt conversation, but I think we should try and wrap things up here. So with respect to that, let's continue the conversation on the issue. We won't change anything until we've sort of heard from people, but from what it sounds like, the general consensus seems to be that this is a point of confusion, so it's something that we should work on clarifying. So feel free to chime in on the issue that Doug started there.
I have one important question. How did you turn the page around?
I downloaded it and opened it in preview, and then
I can't do anything.
That was brilliant. Okay.
Any other last minute questions, thoughts, burning items?
Yes.
Sagi, are you going to be around for a few minutes? I'll talk to you after if you're still going to be around.
But you have something. He looks like he's got something burning he wants to say.
No, nothing particular. No.
Okay. Sounds good. Perfect. Well, thanks everyone. Next week I am away. I can try and attend, but I can't guarantee that I will be able to be here. So I would appreciate if somebody else is willing to take the charge.
We'll take over. Yeah.
Excellent. Thanks all.
Bye bye.
Thanks, Lindsay.
See you.